All right, so I have been with Silver Peak for 10 years. I was working on WAN optimization. I then went into, we did SD-WAN stuff, evolved it. We did take out the router at the branch, take out the firewall, and now we're taking out everything else with regard to SASE and SSE integrations. So I've seen this thing from start to end and can answer just about any question related to SD-WAN that you might want to throw at me, hopefully. I think I can. I've heard them all at one point or another. I want to cover a couple things with you real quick. For instance, there's everything that you're doing here is going through an EdgeConnect. It's running version 9.3.0. One of the interesting sort of novelties of Aruba this conference is that we run early code. So 9.3 is not even available to our customers yet. It's kind of it's in pre-release, pre-FCS, and the entire show is running on it. We're hitting about, you can see here, we're hitting about 100, actually 250,000 concurrent flows. Pretty good bit. You get a couple thousand people all using their phones and doing random stuff. It makes for a lot of traffic. So this is a screenshot from the maybe an hour and a half ago. You can kind of see the gradual ramp. So we're using, again, you guys are going through and using the EdgeConnect with everything you do if you're connected to the trade show network. Now, in terms of bandwidth, that's about, you can kind of see this was 2 days ago, yesterday, and there's today, and then by tomorrow I think it'll peak. So we'll see about 2 gig. You're just kind of curious, like how much traffic does actually that's only hitting 1 gig. These are 1-minute measurements, so pretty good bit. Now in terms of like application breakdowns, we've got the kind of stuff you'd probably expect: Office 365, SharePoint, Facebook. Interestingly, Apple's pretty high up there. I suspect this is related to updates. Here's a breakdown of latency measurements. So one of the interesting things we just added that just showed up in the 9.3 release is that for key applications, you can select up to 50 of them. We will, over time, build up a representation of the actual latency being experienced by the users. So this is derived by looking at the flows on the wire, figuring out the SYN, ACK combinations, the first, second UDP packet. We're working out the latencies, and we break it into 2 categories. There's the gold, or gold here, the orange portion of the chart is showing wireless latency or LAN side latency, and the blue part is showing WAN side latency. So the blue part is how long it took to get across the internet and back, and the gold part here is showing, or the orange part is showing you how long it took to get from the wireless device to the EdgeConnect. It's kind of cool. We can break that down. So we track all of these stats in the SD-WAN router all the time, per minute, per application. We then allow you to create charts and show things. So I thought it was kind of interesting that given how many people there are, 20 milliseconds, 13, 15 milliseconds, not bad for the average wireless latency for these different applications. All right, so I have 3 broad topics that I'd like to cover. I do not know how far I'll be able to get into each one of these. I want to talk a little bit about access security, the acquisition we just did. Everybody's really interested in it, and there's a couple of good reasons why there's a lot of excitement about this addition to the EdgeConnect suite. It's just very practical. Everybody loves it. We're actually I'll tell some stories about it here in a minute. So talk about access. I want to talk about a new feature that I was directly responsible for. It's called App Express. This is a mechanism by which we explore and find the best path through the network to each application specifically. It'll hunt across Zscaler paths. It'll hunt across Netscope and local breakout, backhaul. It has some fancy state machine mechanisms that allow it to kind of hunt down the best path to a given application. And I want to talk a little bit about, and what arguably the nerdiest / more technical bit, but very important, especially in the long run, is we've added GPID VXLAN support, or role-based inspection and integration to the EdgeConnect SD-WAN. So I'll talk more about what that really means, but these are the 3 big things that we are thinking about sort of this year at this show. The big meaty bits of new functionality. Let's first talk about access security. We've needed this for a long time. We've always let's see, be careful how I describe this. We've always relied on a Zscaler or a Netscope or one of these vendors to help us in a customer account. Like if the customer needed certain features, they say, you know what, we want to invest in SASE. and we really like Silver Peak / EdgeConnect / Aruba, but I need to also go talk to Zscaler, or I need to also go talk to Akamai or some other SSE provider. We have to bring them in and make them part of the deal. And that's okay. We've actually done really good with that. We have over 400 active Zscaler integrations, 400 customers using the Zscaler automation that we have in place. It's been there a long time. It's very reliable. It works well. But the time has come for us to have our own. So we want to, we went out, went through this process of acquiring Access Security, and here we are. Now we are not quite as reliant on some of these SSE vendors as we were before. Now, I want to talk about one dimension of access. Now, there's a lot of folks that are going to be discussing it this week. I have come at the Access Security acquisition from the user's perspective first. So my approach to product management is to be as empathic as possible. And the only way you can be truly empathic product manager is if you live the life of the customer. So before I even talked to anybody at Access Security, I went and became a customer, and I found a use case that I was like, you know what, I can use Access to solve this big problem for me personally and for the SEs within Aruba. I want to show you guys how that went. So the idea is that if you can really be the customer, you can design products and features and roadmap items that matter because you know what it feels like. So we were very big into that on the EdgeConnect side. So let me talk about this for a second. This is going to be a little, hopefully you can see this well enough to kind of get the idea. So we have a large demo environment called the SD-WAN, and it has about 120, currently has 128 sites. This is an EdgeConnect orchestrator. Let's see, how much should I back up? So the EdgeConnect SD-WAN system has a controller that's called the orchestrator. It lives typically in the cloud. We'll host it, or the customer can deploy it on-prem. And then the orchestrator controls up to 3,000 SD-WAN routers. So this deployment, you're looking at the orchestrator, and down the left side over here, we're going to be a little cramped for space. I can see that for demos. These are all the appliances that are connected to this orchestrator. So these are all the SEs, some of the account reps, engineers. They participate in this EdgeConnect fabric because it helps us test early code. It helps us demo what it really looks like to run a 100+ site deployment. This deployment has devices all over the world, in Europe, in Asia, all over the place. I'm using cloud hubs. If you notice over here on the left, this entire deployment, it's hub and spoke model, but it doesn't have any physical data centers at all. The hubs are all Google, AWS based, Azure based EdgeConnects. We've got some Megaport, got some Equinix. You really don't need to deploy EdgeConnects. You don't need to make the data center your hub anymore to talk between branches. That's just kind of out of fashion. Cloud hubs work really well. My main point is that this deployment here has a bunch of supporting applications that we use to run it. For instance, I've got a ClearPass server, Splunk, collecting IDS, IPS information. We've got a ping plotter instance, a couple of jump boxes, IPFix, a picture scrutinizer, NetFlow collector. All these applications are sitting in AWS, and this was the prior to Access state, open to the world. And they kind of necessarily had to be because I need the SEs to be able to come from anywhere. I need them to be able to get to these supporting apps so they can do demos. So they can say, the customer says, what do EdgeConnect IDS IPS events look like in Splunk? I want them to be able to go and log in and show that. The problem this has created, and you can see over the top right, if you're an EdgeConnect SE, you're going to have a list of these externally facing applications. They're open to the world. That is the main point. This has always made me nervous because I have to manage credentials on each one of these applications. I have to worry about, all of this attack surface is just open to the entire internet. My security groups allow all my port forwards in my garage over there are allowing inbound access to the orchestrator, to an RDP server, to a ping plotter instance. So Access solves this problem for me. What they are good at and what I really like, and I think people are going to, what people are really going to get out of Access is the ZTNA component. The client, the VPN mechanism that these guys have going, it's probably the best, probably the best. They're also doing the SWIG and CASB stuff and more of the traditional, kind of what you'd think of as Zscaler Netscope features. And those features continue to mature. they're solid, they work now, but where they really shine is on the ZTNA side. So let me show you what, so here's the prior state, all these publicly facing apps. I'm worried about keeping up with passwords and patching and all this stuff. And here's the state after Axis. So what these, you guys been briefed on Axis yet? Have they talked to you about? Oh, okay, good. Well, maybe good or bad. So Axis, one of their real special aspects is that they have these agent and agentless applications. The agentless applications are really where it's at. They're very cool. So what you do is you go into their portal and you configure these apps. And I find myself wanting to walk up to the screen. You configure these apps. It looks a little bit like Okta. Like, you know, you log into Okta, you have your IT guys assign applications to you, and you can click the box and log in. It's very similar. You go into the Axis management interface and you configure apps. You make them available in this portal. So then what happens is you're sitting on your laptop here, and if you're a user in the enterprise, 10, 20, 30,000 users, they would all have one of these sort of dashboards. Our SEs, that's my main point here, the SEs have this dashboard. They can log in and they can click those boxes. When you click the box, it proxies your traffic through the Axis portal, that you see on the right, backwards across a WireGuard tunnel to a thing called a connector. That connector is it's the cool part. The connector is this little piece of software. You can, as an AMI, you can deploy it in AWS. You can put it in a VMware server in your garage, as I have over there. And the connector acts like a little, a reverse proxy. So let me actually show you real quick. Let's do it. So let's go to let's pull up our, let's go, we're still on real estate here. So this is what the user would see, this kind of page. And what these guys have done so well is if I click on one of these things, like let's say I click this guy, you'll notice it gives me this little window. I can hit open RDP. So this is going to allow me to get a remote desktop in AWS right in my browser. And you might say, well, how did it do that? This RDP server, this device, is not accessible from the internet. So I'm sitting here at the Venetian, and I'm not like allowing traffic from the internet to get to this jump box, to get to this AWS-based Windows machine. What's happening is my traffic is going from me. I'm going to the Axis web portal. I'm clicking on it, and my traffic is being tunneled down that blue line into the connector, and then it source nats into the connector's source IP, so that the traffic is going to these VPC applications like the RDP server, like ClearPass or whatever. They will see the source IP of the connector itself. So what this allows you to do is I can front end all of these apps such that the only way you can get to them is by going through the Axis agentless portal. That's really cool because now I don't have to contend with, again, securing each individual application. I authenticate the user once in the Axis portal. They click on it and they can just drill and go straight into anywhere that they choose within the SD-WAN management environment.
Sorry, just to back up on that, are we using Axis to establish and authenticate the session? And then is traffic building its own tunnel directly to the endpoint, or is user traffic passing through Axis itself?
It is passing through. So like this thing that's happening right here, this desktop we're looking at, this is coming across, it's coming back across that blue line through the Axis portal into my browser. So this session, you can do SSH, you can do any application this way. It is going across that WireGuard tunnel from the Axis portal to the connector.
So is there an option not to go through Axis with your data?
I don't, there's not an obvious one for it, and I gotta be a little careful so I don't want to speak for their roadmap. I think that there is something coming for that, but currently it has to go through it, which is interesting because we've had some folks already say, well, look, I like the traditional mode of I'm going to connect from, I have my Pulse client, or I have my traditional VPN client, and when I connect directly to the data center. I don't go through some third party. We have VIA for that. Aruba still has the VIA client that you can use for the truly traditional, I'm going straight to the data center. But that's really not how these guys are thinking about it. They're very much about the policy control point, the place in the network that's making the authentication decision, is that access portal. So you authenticate against that portal. You can plug it up to your IDP, plug it up to HP SSO, which is what I'm going to be doing hopefully next week. And that thing is providing the authentication and access for everything on the other side of it. So this is tricky because I don't know how much time to. I really want to kind of go through this and explain it in detail, because it has made my life so easy, because I do not have to constantly sweat securing each one of those apps, making different security groups, controlling access to them. All I do is allow the connector's source IP to talk to. It's all I need in my security group. Just permit the source IP of the connector, because all the traffic will come from the connector. So this is their ZTNA story is really strong. They've got some other stuff. I can access loopback IP addresses within my SD-WAN fabric across the connector. You can also have it do SWIG and CASB functions, so your traffic goes through the cloud like it would for Zscaler, and then it leaves on what's called a public connector and comes out to these applications, Salesforce, Office 365. They have a DLP mechanism. They have a pretty sophisticated CASB mechanism as well. So if you want to filter or monitor user traffic through these critical applications, you run it through the access portal. This is not a whole lot different from the way Zscaler or the other SSE vendors do it. What is different is the way that this agentless application infrastructure they have. It's really cool.
Can I ask you a question?
Yes, ma'am.
So all the traffic is going through this access, right?
Right.
So if I have a distributed environment where I've got lots of branches, does that mean I need an access server in each of my branches for latency reasons?
There will be so they use a couple different mechanisms for optimizing the AWS globally accelerated endpoints, which allows you to on-ramp to the AWS's middle mile, which they then use their POPs. So it's really quite well optimized. But at each branch location, let's see if I have. At each branch location, even if the user doesn't have the Atlas client, the EdgeConnect, the SD-WAN router, is forming a traditional IPsec tunnel to access. So if you're a user and you're sitting at a branch location and you want to access something that is on the other side of in a data center or out on the internet, and you want to run it through your CASB SWIG mechanism, there's a tunnel that's formed from the EdgeConnect to the nearest access POP. That's how Zscaler and Netskope work also. You take your SD-WAN router and you create an IPsec or GRE tunnel to the closest Zscaler or Netskope POP, and then traffic gets routed into the EdgeConnect SD-WAN router and through the tunnel through the SSE mechanism. So you only need the connectors in places where you have an application that you want folks to be able to get to. That's the way of thinking about it.
Yeah, because I'm struggling a bit, because we're hearing, that data is moving closer to where the users are, right? They're being stored, especially on an international scale. And so but here I'm hearing centralizing where you're putting your traffic through, and the two seem at conflict to me.
So this thing here looks like it's a central access, but there's actually like 30 of them.
Okay.
They're all over the place.
Okay.
They use AWS, they use Azure. I think they have some Google POPs as well. So this represents the electronically closest one to that user.
Okay.
So it has a mechanism by which it does a DNS query. It gets back the closest IP address for that access, the closest access POP, depending on where you are in the world. And then it connects to that access POP and two other ones and works out the latency. It figures out which security stack is the closest one. So this is more a function of how many POPs they have and how well they've geographically distributed them. But there is an assumption that, again, a lot like Zscaler or Netskope, there'll be a bunch of POPs spread out all over the place. The user doesn't really think about that. They just connect to whichever one is closest to them. So you might say, well, I thought this was an EdgeConnect discussion. One of the things we want to do, and I'm just going to say it straight up, we really want to put the connector in the EdgeConnect. What we want to do at the EdgeConnect is bring the SSE integration, bring this access technology into the world of the EdgeConnect fabric. So one of the things we'd like to do then there is put their connector in the EdgeConnect. Thank you, sir. Put their connector in the EdgeConnect. That way, no matter where you are, if you're out on the internet somewhere and you want to access some application that's located at a branch office, perhaps, or in the data center, you connect to the Access portal. You then get tunneled across the internet into the EdgeConnect, and you pop out of the EdgeConnect through the connector into the local application. So there's this Access, the ability to do the deeper security functions, the deeper security inspection and whatnot, is something that the EdgeConnect needed. Like, we needed a deeper security stack that we could connect to that wasn't some other vendor, that wasn't Zscaler or Netscope or one of those guys. All right, it's so tough, guys. I have these three big things that there's no way I'm gonna get through. I have 9 minutes left. I want to briefly talk about this. I want to show you guys this new thing. I can go through it really quick. I can explain what it does. So if you guys are familiar with SD-WAN, one of the things it does well is paths. So the more underlays or the more internet connections you give an SD-WAN router, the better it will perform. It's just fundamental to how it works. For instance, at my home office, I am blessed enough to have a Starlink connection. I have a Starlink residential. I have an AT&T optical connection, and I have a Comcast cable connection. 3 high-speed unmetered internet connections. That's ideal for an EdgeConnect SD-WAN router because it will figure out, for a given application, for a given time, for all kind of parameters, it'll figure out which one of those internet connections is the best one to use for each application that you have, that your enterprise interacts with. If one of those underlays or one of those connections drops or fails, the users don't even notice it. 600 millisecond failover from one provider to the other. So we've added in this most recent release this new thing called App Express. Let me show what it does. So first of all, it scores the latency for all the flows. I showed this earlier. It's this thing here, the chart that shows the blue, that's the WAN side of the latency. The gold is the LAN side. So it's scoring the performance characteristics of all the connections that the user creates. It gives you reports. It'll show you over time the latency for a given application. Now, what we've done in this most recent release, we feed these latency measurements. So as we're watching flows across the network, we feed these latency measurements into an algorithm called AppDex. We did not make up AppDex. It's actually rather old, been around for a long time, but it's really useful. What it does is it normalizes multiple inputs into a score. So you take, up there at the top, imagine I contact Zoom or I connect to Salesforce. The EdgeConnect scores that flow. It says, oh, well, you got 80 milliseconds and you had this much loss. It feeds those metrics into this AppDex algorithm. You give the AppDex algorithm a T and an F boundary. The T boundary is the little area between satisfied and tolerable. And the F boundary is the thing between tolerable and frustrated. So it's like Plinko. You drop in latency measurements and they fall into either satisfied, tolerable, or frustrated. And it literally means if the latency is less than, let's say, 30 milliseconds, then that's satisfied. If it's between 30 and whatever you specify, let's say 500, then the users are tolerating that behavior. And if it's above 500 milliseconds, then we would classify it as frustrated. So you feed these measurements into these buckets, and you do a little bit of very simple math, and you spit out a number between 0 and 100. So each application is scored for quality across each path. So if I have multiple internet connections, you'll see here that it'll build up and give you a score of Zoom connectivity across Starlink, Zoom connectivity across AT&T and Comcast. So you can see here I just came from a meeting. I talked about this for about 45 minutes. App Express went through all this detail, still ran out of time, so I'm certainly not going to be able to do that today. But all these slides are in the deck that you guys will end up getting. But I want to walk through this quick use case because this is kind of I think this is a pretty good example. Imagine that I have, my office is closed. It's like 6 a.m., no users are at the office yet. This office location has 3 internet connections, Xfinity, AT&T, and Starlink. What you do is you tell, for each application that you care about, you can do up to 50. You tell the system what is the target QoE that you want the system to search for. Now, the target QoE, that's like saying, for Zoom, I want you to find the best possible link. Keep looking across all the links until you meet the target QoE of excellent. So what will happen is, again, 6 a.m., no users are in the building. The EdgeConnect from each branch begins polling once every 10 seconds by default, begins polling across each internet connection to the key applications specified, Zoom in this case. It scores the characteristics of the connection. So Starlink got a 72, AT&T got a 98, Xfinity got an 89. Then when the users arrive, when they come into the office, the system already knows which link is the best one to put them on, because it needs to make a decision. I'm gonna route someone straight to the internet. I need to put them on one of 3 internet connections. Which one should I use? Now, in previous releases, we would pretty much just do a weighted load balancing based on the current available bandwidth. This thing takes it a step further. Now it says, all right, well, we know that the ping QoE for this link here was really high, so we put the users on AT&T. We then see that we then watch the user flows, and we say, yep, those user flows are meeting the target QoE. So there's a mechanism that's pinging to find the best path. When the users come into the office, we put them on what we think is the best path, and then we look at the flows they're creating to confirm that it's behaving in the way that they're getting the performance that we expected.
I have a question. Can you have it aggregate rather than disseminate?
It aggregates all the flows for a particular application. So if there's, like, let's say there's 3 people here, they're like in this example right here, there's 2 folks, they're both opening connections to Zoom. It will take each one of their flows, average them every 5 minutes, create an AppDeck score, and it'll say, all right, for getting to Zoom from this branch location across Uverse, we are getting a score of 97. So it aggregates all the individual flows by application to create.
I was thinking of aggregating the Xfinity and Uverse both together. You might actually get a better score than
Yes,
any one.
that's right. Let me show you. You're exactly right. I see what you're saying now. Give me 1 second. I'll show you in 2 minutes and 57 seconds. So right now it's 9 a.m. Users come in. They get put on this. It looks good. 97 score. 9:50 in the morning, later in the morning, something happens and my Uverse connection starts to decay. The quality of experience starts to drop. So we start scoring flows with a lower QoE. The system says, hey, you wanted excellent QoE for Zoom, but your users are not getting that now. So it will put the next user that starts a flow on the next best path. So it will put them on Xfinity. It will then watch those flows and say, yep, we moved the users to a new path, and now it looks like they're getting a better performance. And over time, everyone will gradually make their way onto Xfinity. Now, this is what we call the local breakout use case. Local breakout is direct to net, right? You're not going through Zscaler, you're not backhauling across a hub or anything like that. It's a straight local breakout. The thing that you were talking about is, wait, let's get to this one, is this example. So now what I have is, I have all three internet providers. What the EdgeConnect does, if you have another EdgeConnect on the other end, so if you bookended, if you have an EdgeConnect to the branch, and then you put an EdgeConnect in AWS, in Azure, you can have X number of them. You saw that system I was showing a minute ago had lots of cloud hubs. What happens is the traffic leaves from the branch, it gets combined into what's called a bonded tunnel, a bonded overlay. So you send the packets across the best 2 internet connections simultaneously inside the tunnels to the cloud hub, and then you NAT into the cloud hub's source IP. This is called ruggedized first mile or protected first mile. And why it's cool is if I can just pull the plug out of any 2 of those, and the user will not notice. They will not, it's utterly transparent. We call this HA mode. And it works by sending, if I'm talking to someone, it sends the packets, the data, we call the data path packets across the best link, and it sends a copy of those packets across the second best link. So if you lose the packets on the way across your best link, the copy of the packet just shows up a millisecond or 2 later on the second best link. So and it interleaves and puts them back together. It's like having, like the president drives somewhere in 2 different black trucks kind of thing. You're sending the traffic 2 ways simultaneously to protect in cases where you might lose the packets. The EdgeConnect has always done this, but what App Express does is it now will figure out, to get to Zoom, should I backhaul through Northern California, or should I backhaul through North Virginia? It will dynamically work out, if you have multiple hubs, to get to Zoom, which way should I go? So in this way, you are, like you said, you are aggregating. You're setting it up such that you can send packets across multiple providers at the same time.
Does this also have controls so you can, if you have metered connections, you can control how it uses those?
Currently, no. We won't auto shut off the meter. This is a problem, by the way. Like people have to be kind of careful about burning through LTE meter usage. We rely on the LTE provider mechanisms to signal to the user that, hey, you've blown out your 50 gig allotment. We also provide reports that break down the amount of usage per device, but we don't cut them off yet.
Okay.
There's not an aggregate per month byte count that we track, although this has been asked for quite a few times.